Hi, Assalamualaikum and good day. Today you are going to learn about implicit differentiation. This is the objective of today's lesson. Hopefully, by the end of this session, you are able to differentiate functions using implicit differentiation. Before we go further, let's see the difference between explicit and implicit function first. For explicit, the function can be expressed as an equation in terms of one variable only. For example, y equal to 2x squared minus 3x plus 1, in which y is represented in terms of x. As for implicit, the function cannot be expressed as an equation in terms of one variable. For example, x squared minus 3xy plus y squared minus 2y minus 4x equal to 7. Here, y cannot be represented in terms of x, so do x cannot be represented in terms of y. To determine dy over dx of the implicit function, you need to differentiate both sides of the equation with respect to x before solving y in terms of x. This process is called as implicit differentiation. Following are the steps to perform the implicit differentiation. First, you need to differentiate each term of the equation with respect to x. Then, move all dy over dx term to the left and all other terms to the right of the equation. Finally, factorize dy over dx and simplify. Following are the example on how to do implicit differentiation for the algebraic function. Differentiate x plus minus y using sum and difference rule. The answer is 1 plus minus dy over dx. Differentiate xy using product rule. The answer is x dy over dx plus y. Differentiate x over y using quotient rule. The answer is 1 over y minus x over y squared dy over dx. These are the example on how to do implicit differentiation for the trigonometric function. Differentiate sine x plus y using sum and difference rule. The answer is cos x plus y plus cos x plus y dy over dx. Differentiate sine xy using product rule. The answer is x cos xy dy over dx plus y cos xy. Differentiate sine x over y using quotient rule. The answer is 1 over y cos x over y minus x over y squared cos x over y dy over dx. These are the example on how to do implicit differentiation for the exponential function. Differentiate exponent x plus minus y using sum and difference rule. The answer is exponent x plus minus y plus minus exponent x plus minus y dy over dx. Differentiate exponent xy using product rule. The answer is x exponent xy dy over dx plus y exponent xy. Differentiate exponent x over y using quotient rule. The answer is 1 over y exponent x over y minus x over y squared exponent x over y. These are the example on how to do implicit differentiation for the logarithmic function. Differentiate ln x plus minus y using sum and difference rule. The answer is 1 over x plus minus y plus minus 1 over x plus minus y dy over dx. Differentiate ln xy using product rule. The answer is 1 over y dy over dx plus 1 over x. Differentiate ln x over y using quotient rule. The answer is 1 over x minus 1 over y dy over dx. Now, refer to example 1. You need to find dy over dx of the given curve. To find dy over dx, you need to differentiate every terms with respect to x. Differentiate x squared, the answer is 2x. Differentiate 3xy using product rule. The answer is 3y plus 3x dy over dx. Differentiate y squared, the answer is 2y dy over dx. Differentiate 2y, the answer is 2 dy over dx. Differentiate 4x, the answer is 4. And differentiate 7, the answer is 0. Next, move all dy over dx terms to the left and all other terms to the right. Then, factorize dy over dx and simplify. You should be able to obtain the following answer. Let's proceed with example 2. You need to find dy over dx for the given equation using implicit differentiation. To find dy over dx, first differentiate every terms with respect to x. Differentiate xy using product rule. The answer is x dy over dx plus y. Differentiate 3x squared, the answer is 6x. Differentiate 2 cos x plus y, the answer is negative 2 sin x plus y minus 2 sin x plus y dy over dx. Differentiate exponent 3y, the answer is 3 exponent 3y dy over dx. Next, move all dy over dx terms to the left and all other terms to the right. Then, factorize dy over dx and simplify. You should be able to obtain the following answer. Refer to example 3. You need to find dy over dx of the given equation using implicit differentiation. To find dy over dx, first differentiate every terms with respect to x. Differentiate 3x squared y using product rule. The answer is 3x squared dy over dx plus 6xy. Differentiate 4y cubed. The answer is 12y squared dy over dx. And differentiate tangent of x over y. The answer is 1 over y secant square of x over y minus x over y square secant square of x over y dy over dx. Next, move all dy over dx terms to the left and all other terms to the right. Factorize dy over dx and simplify. You should get the following answer. In order to check your understanding on this lesson, please do the following exercise. In the next lesson, you are going to learn on how to determine the equation of tangent line.